Welcome back to Cricket Aviation. My name is Jim Payne, and this is a completed horizontal stabilizer for a CriCri. Now, if you're familiar with the CriCri, you might already know that this is what the designer recommends you build first, is this horizontal stabilizer assembly. Now, I did this horizontal stabilizer assembly in conjunction with my vertical tail assembly, primarily because of these fittings that are located on the horizontal stabilizer. These fittings are attached to the spar inside of here, and it's much easier to align these fittings onto the vertical fin if you build the vertical fin spar and the horizontal fin spar at the same time. It's easier to get them squared up because you can set them flat on a table. You can get these bearings installed and the bearing supports installed and get everything squared up and aligned. So I'd recommend that you build the vertical fin spar and the horizontal fin spar at the same time. Now I went ahead and finished my vertical fin and finished the rudder because I wanted to get that test fit onto the rear fuselage, and then I came back and finished the horizontal stabilizer here. So the major hurdle you have to take care of in order to start this project is to make these bearing fittings and the flight control fitting here, and those have to be milled out of solid bar stock. So that's the major hurdle that has to be taken care of before you can start this. But once those are created, it's pretty easy to build this assembly. So go ahead and please like the video, subscribe to the channel if you want to get notifications when I release new videos, and check out the links in the description for Facebook and Instagram, and stick around and we'll build a horizontal stabilizer.
Yes, I'm building the world's smallest twin-engine airplane.
I think the first thing that we need to talk about when working on the horizontal stabilizer is these fittings that are required to attach this to the vertical fin on the back, because this is the T-tail configuration, and also the push rod fitting here that controls the position of the horizontal stabilizer. If you've looked at the plans for the CriCri, you know that the horizontal stabilizer is the first thing that the designer recommends that you make. Obviously, these are the biggest hurdle you have when starting this CriCri project, is how do I make these fittings? Now, these are not difficult to make, although, you know, the designer really designed this airplane to use a T-stock of aluminum to be able to cut these out of. However, you know, if you've been around the CriCri long enough, you know that you can't buy T-stock 2024 T3 material like this to be able to just, you know, cut these off in length and you know, maybe mill down the top. So what we have to do is we have to start out with a solid block of aluminum like this, and we really have to just mill these fittings out of a solid piece of aluminum. It does require a mill, doesn't require CNC. I made these on a mini mill from Harbor Freight 10 years ago, and these are more than adequate for being put on a CriCri. And you know, all of the rounding that has to be done around the bearing hole here and around these corners here can all be done on a sander. So it's really just a matter of putting this in a mill and just milling this T-stock, just being able to get, you know, a path going down in here. And what I did is I cut these with a 1/4-inch ball end mill on my mini mill. So the radius in here is you know, an 1/8 inch radius, because it was a 1/4-inch diameter end mill, which seems to work out pretty well. And you know, these radiuses in here are the same. So I used just that one tool to do all of the cuts on all three of these pieces. And these pieces here, I think I made these, you know, like end to end out of my solid piece of aluminum. I cut these at the same time. I think I cut this one separately because I cut a bunch of these all at once, and it wasn't too bad to do. You know, once I was able to just cut the profile of the T-stock, and the way that I did that is I ran my 1/4-inch bit down on either side of this 4mm thickness that I wanted, all the way down to about the base. Then I flipped this on its side, and then I ran another cut across here and just actually ended up cutting out this piece. I didn't really do a milling operation where I milled my way in on each side or down and just got rid of all the material. I actually cut out a rectangle on either side of this when I did these, and that worked just fine. And then once you get these cut out, you can drill these either in your mill, and now I had a digital DRO on my mill, which helped me out significantly, because once I had, got these cut, using a DRO, I was able to just easily jump from hole to hole to hole with measurements that I had already, predefined on a piece of paper, and said, well, I need to drill this hole here, and then we'll go down there, this one, jump over here, do this one, and on down. And then I flipped it sideways, and I did the same thing. And as long as you keep a accurate starting point, so you know where the edge of your material always is, then you just come in from the side and do these and drill these holes here. These holes here, including this one here, need to be reamed at this 14 millimeter, which is the size of the bearing. So you do need to purchase a reamer to ream out these holes. And the only really critical measurement on any of these fittings is your edge distance around the outside of the hole here. So that's really what you want to pay attention to when you're cutting these out, is make sure that you're constantly measuring from this hole distance out to the edge, and make sure that you've got your minimum edge distance, what I think is 4 millimeters on these. And so you do have to be careful where you place this hole, and when you ream this out, that it isn't too far one direction or the other, or you're going to end up not having enough material around the edges when you're done. But this is the first hurdle to get through, is to make these fittings. I'm not going to show you how I made mine, because like I said, I made these 10 years ago, and they're not difficult to do if you know how to use a mill. You can also find somebody maybe that can make these for you. We're hoping to have these available as part of our kits and parts that are going to be on our website eventually, but I don't have any of these at this point to sell. I'm trying to focus on getting this first airplane done, and then go back and figure out the best method of producing these for for other people. But anyway, so yeah, you need to figure out how to make these first, and then you can move forward really on working on the spar.
So the next thing I'm going to work on is the rudder and fin spars, and the elevator or horizontal tail spars. The reason I'm kind of trying to do these together is it involves a lot of the same processes. I've got the spar web for the horizontal here. I have drilled the holes, I don't know if you can see it here, in the center for this center plate, and I've also pre-drilled the center plate for the middle holes. This doubler that goes on here, I can align that with the holes that are in there. That gets that in exactly the right spot in the center. These fittings will actually go on either end of that doubler, like that. I already drilled the holes in those fittings, so once I get those aligned properly, I'll just drill the holes all the way through the spar and the doubler that's there. This is the control rod fitting that we'll deal with that one later. But the goal is to get these two angles cut to the right height, and also tapered along the other edge. These two spar caps actually attach to the opposite side of this on either side once they're cut. I've got some of the parts over here for the vertical tail and rudder spar, basically. So this is the spar web for the vertical spar, and I've got some angles here that need to be cut down, but these angles are going to basically attach on the ends here, and then there's some bearings that go on the end. But the top of this is what attaches to this. So these spars that we're putting in here are going to have a bolt hole that go through, and of course this will eventually come like this, and these spars that we're going to cut here with the holes in are going to attach through a bolt through these bearings here. So I'm doing these at the same time so that I can make sure that this whole thing is perfectly square. We're going to get this done first. We're going to line these properly with a rod that goes through the bearing holes, and then we'll make sure that when we go to attach and drill the holes for these spars here, that we have this thing perfectly square. And so I'm going to try and do these both at the same time, and that's why we're going to work on this next. And these get glued together and get riveted together. We'll go through the same process on both, where we're going to glue everything, we're going to allodyne it similar to how I did the wing spars, and then we will move on after that to actually move through finishing this process. So the first thing I think I'm going to do is actually switch out my vacuum tabletop and put back my T-track table so that I can mount a board on top of here, and we will cut a slot to hold these two spars in so that we can cut these, again, similar to how I did the wing spars. We're going to do this one first, get these all cut. We'll get these glued on top of this, and I'm going to pre-drill all the holes for all the rivets in the spar caps that go on here so that once they're glued on top of this, I can go back later and just drill out all the holes that are already marked and drilled through the cap. Alright, that's what that taper looks like on the elevator spar when it's cut on the CNC machine. I got some cleanup to do. We'll pop it out of there, clean it up, and we should be good to go. It's probably hard to see the scale of these things on camera, but these things are tiny. And what's nice, look at what the CNC does. It cut that angle off the other side and made it the thickness perfect. I mean, that's as good as you get. But these things are absolutely tiny. I mean, this whole thing looks flimsy tiny, but apparently that's all you need. Same thing on that. Look at that. Taper cut off. Wow. So much easier to do it by machine than by hand. So I finished polishing up these angles that these spar caps for the horizontal elevator. I got these all cleaned up. They look great. They're gonna work good. So now, I thought I'd show you while I'm doing this. These are the fittings, and there's still some finishing work that needs to be done on these fittings. This radius has to be put on the end here, sanded off. These need to be cleaned up a little bit. But these are the fittings that are gonna attach here. There's one that goes here, one that goes here. There's two that go here. These are the fittings that will end up going into these mountings here on this other thing that I'm using. And these are the bearings. These are metric bearings that get pushed into here and spot stamped in place. These are a little tight because they're I did remount these holes to the proper size, but this gets put in between here. There's a washer and a few other things that go in there, and that is what holds the elevator onto the tail and creates this T-tail configuration on the CriCri. And there's one that goes, like I said, on either side here. So you can see how that's going to work. I thought I'd show everybody what I did here before I glue this elevator spar. These are actually the angles that I'd already purchased for the front fuselage sides. I just stuck this on my CNC table because this is perfectly flat. I was able to just clamp down in a perfectly straight line this angle with the clamps on my table. I then put the piece of webbing that has to go in here that the caps get glued to, and I spaced this cap on the other side exactly the right distance away. I am putting down some wax paper between here, so there's going to be wax paper here. And then to hold this down, originally I thought I was going to do something different than what the plans recommended, which was to use screws through the caps, just because I wasn't sure I could find that small screws. And I thought, well, I could probably just put some weights or clamp these things down. But these things are so tiny and so flimsy that, to be honest, I couldn't figure out a way of holding these in here. And they're not perfectly straight. You know, whenever you cut angles, they tend to warp a little bit. just because the stress relief of you know, cutting off part of the angle on either side. So I did drill holes slightly smaller than 3/32 of an inch, you know, about every 6 inches or so. So I am going to screw these down to the web while it's drying. I couldn't figure out any other way to do it. What I did is I went to the store, you know, just in case you can't find these tiny screws. I actually found a pack of these small hinges that were only $2.25 at the hardware store, and I'm just going to use these screws to these brass screws that are in there to screw this down while it's being glued. So I'm gonna go ahead and put the parts back in here and start getting the glue ready, and go ahead and glue this in, and then I'll show you what it looks like when it's all done. All right, so I've got the spar now glued, the spar caps glued onto the spar web. I did a little bit of cleanup. I just kind of wiped around the top of the caps with some acetone. But yeah, this looks pretty good. I'm just gonna let this dry, and we'll pop it back out. So the epoxy dried on this spar web, so I've pulled it out of here already. I'm just going to go around it and just clean up some of the glue that's on the outside. We'll just sand it off. It's just a very light coating that ended up on the outside, but it looks pretty good. So the next step with this is going to be to drill out all the rivet holes to the final 3/32 size. We are going to flip this over onto this side, and we are going to install this doubler plate that goes on here. So we'll drill all these rivet holes for this plate. I had already located the holes in there, and of course they align with the ones that were already in spar, so we know exactly where that needs to go. I spent some time while the glue was drying just final sanding and shaping these fittings here. We had to round the ends here for the bearings on both of these. We rounded the edges here so that they will fit on top of this doubler, like so, like that. And so we'll actually get to the point where we will locate all of these holes for these brackets to be installed also. And then once I get all the holes drilled, we'll allodyne this. We'll allodyne these fittings here before we install the bearings, and we'll get everything ready to rivet. Okay, so a few hours ago, I went ahead and glued this doubler on here that I talked about before. It's still a little tacky, although I was able to take the weights I set on top of it off and clean it up a little bit. I've got a nice tight glue joint all the way around. So we're just gonna let this sit a little while longer, and then we'll get this all drilled. So while this part's drying here, I thought we'd talk about bearings, since we're now gonna have to install some bearings as part of this elevator assembly for these fittings that are gonna mount on here. The bearing sizes that are used on the CriCri, there's 3 different sizes. There's a 4mm, a 5mm, and a 6mm spherical plane bearing. That's what these are considered, a spherical plane bearing. Those bearings are used in several places. I think there's at least 30 different bearings that are used on the CriCri of those various sizes. In the tails for the flight controls, for the flaperons, they all use these same type of bearings. Now, there's several different brands of these bearings, and I wanted to talk about that a little bit because I've come into some issues with purchasing of these bearings, and these things are expensive. The best ones you can buy are really the SKF brand. That's kind of the standard brand. It's the one that's recommended for the CriCri is SKF. Depending on where you find these, though, these can be as much as $30 a piece. And as you can imagine, if there's 30 bearings, it's a lot of money in just bearings in this airplane. So the tendency is to not buy SKF and to go with some different brand, because like I said, there's other brands that are made. I've run into various problems with that, though. So I've got here an IKO bearing, I've got an SKF bearing in the box here, and then I've got some no-name brand bearings. And what I have found out is the SKF quality bearings, they're basically all the same. All the ones that I get are a nice snug fit. They all have actually the SKF logo stamped on the side. And you know, I think the quality that you're getting, if you go with SKF, I don't believe you're going to have any issues. However, I have found that the IKO brand is also very good. So this is an IKO bearing, and hopefully you can see on the screen here. So it actually has IKO stamped around the outside, and it says GE5E because this is a 5mm bearing. I found that the IKO brand is really, from what I can tell, just looking at it anyway, as good as the SKF brand. So I would actually use IKO on my CriCri, you know, instead of SKF. I am actually using SKF, however, though. But these do look like really good bearings. Now, what I will say, though, is the SKF always come in a nice fancy box like this. And they have one bearing inside of each box. When I bought IKO bearings and I bought some other different brand bearings, they just come in a little bag like this. And one of the issues that I had with the IKO, for example, was I got some IKOs that I bought, and I bought all these from the same company. I think it was National Precision. The IKO brand that I got, some of them showed up with the IKO stamped on the outside. It says Japan on it, and it's got the, you know, all the information on it. But then I also got other bearings that look just like this that had no markings on them at all. I don't know what these are. They're not stamped on the side. And of course, I talked to the manufacturer, and their excuse was, or the distributor, and what they told me was that, oh, well, some of these came from a plant in Mexico, and some of these came from a plant somewhere else. Well, I think what this is there's a lot of China brand bearings that are out there that they're not made as well. These are actually loose inside of here. This ball in here, now maybe it would tighten up once I put it in the hole and spot stamp it in. Maybe it'd tighten up. I'm not really sure. But I can tell physically by looking at these that these two bearings that don't have stamped IKO on them or SKF are not as good of bearings. They just don't seem to be quite as good. Now maybe they'll work just fine, and you can get these very cheap. I mean, if you're buying actual China bearings, I've seen those for less than $1 a piece. But again, I would be concerned about, you know, how long are they going to last? You know, what are the tolerances? Are these going to start getting loose? You know, are they even going to be loose after you install them, which is not good, you know, in either sense. So I would caution you, if you go with anything other than SKF, just be sure that what you're getting actually has the marking stamped on the side of the bearing, because that's the only way you know it's not a bearing from China. And the SKF brand will also be stamped just like this IKO. It'll say SKF on the side. Like I said, these, I don't know where these came from, and I certainly wouldn't have wanted to pay the IKO prices for these bearings if they are not IKO brand. Because these IKO brand, I think, are around $12 a piece. You know, and the price varies. They're usually about half of what the SKF is. But again, it depends on where you're buying these from and which supplier you get. But if you want to just stick with SKF and spend the money, that's the best way to go. But like I said, the other brand that I would recommend is IKO. Everything I've got from IKO has been decent quality from what I can tell, at least just by looking at it. So, and it's also a reputable brand from Japan. SKF is obviously, I believe, made in, well, it says made in the Czech Republic is what it says on here. But I think the SKF company is a Swiss company, I believe. So anyway, I just wanted to mention that before we get into some of the bearing things. Now, this is a problem, obviously, putting metric bearings, which I don't really have a choice because there isn't an equivalent, you know, inch or imperial threaded or imperial size bearings that I can buy. All of these small miniature bearings are all in metric. And obviously with metric bearings, I cannot use standard aircraft hardware, aircraft bolts. Now, we'll talk about this a little bit more later, but one of the things I am looking at is using metric hardware that is at least the same or similar specification in strength to the aircraft hardware equivalent. Again, we're putting these bearings in an aluminum fitting, and we're putting a steel bolt in it. I'm not too concerned about the strength of the bolt, but I don't want to go into really trying to modify these bearings or putting a sleeve in them or doing something to try and make an imperial bolt fit. I could try to do that, but I'm thinking that it's safe enough to use good quality metric hardware in the aircraft, at least in the places where we're using bearings. Everywhere else that I'm just putting a bolt through a hole, I'm making all the holes to an equivalent imperial size and using an actual aircraft hardware. But again, just wanted to point that out about these bearings, since we're going to start getting into that shortly with this tail assembly. So I started working on trying to attach these fittings here. Hopefully you can see this here, a little bit of shadows around here. I ran into some problems right off the bat. They tell you to use a block of wood and just cut a block of wood that's supposed to space these properly to the dimensions in the plans. I was able to just mill a block of aluminum. I had some sitting around to just make a perfectly square block. That was easier for me to do, but you can use wood. I just wasn't sure I could cut wood accurately enough to make this all fit together. As you can see underneath here, I had that doubler plate, glued down into the correct spot, lined up with those, pre-drilled holes within the spar web and this doubler here. Now I was having a hard time keeping all of this from just floating around all over the place, and I couldn't keep any of this straight and trying to drill it. It kept moving and so forth. So what I did is I drilled 2 of the holes on this one fitting first, and the reason I did that is because I already knew where the edge of this fitting needed to be, because it needed to be lined up exactly with this doubler on both sides, because I'd already measured it and figured out that I had accurately cut this doubler and accurately spaced these fittings with this block, and it came right to the edge. So I went ahead and drilled 2 of the holes in there first, and I squared this fitting up perfectly. I aligned it with the top edge here so that at least this fitting is not going to move. And then what we're trying to do here is, number one, make sure that the spacing here is exact so that when this fits into the tail section, that these bearings are in the correct spot. But the other thing that we kind of want to do is make sure that that we don't have any misalignment here with these bearings up and down. And so again, we're trying to also make sure that we have this perfectly straight and parallel with the spar. So what I'm doing now is, now that I have this one locked in, I can move this one up or down and verify that the spacing here, or that this is exactly parallel or not, even just by moving one of the bearings. And I know I'm going to be almost exactly flush on the top here with this fitting, just because this was all cut very precisely, not only on a CNC machine, but on a mill. So I know all of this is gonna be really close. But I don't really have any way of verifying that I've got this perfectly parallel to here, other than just looking at the spacing. I did figure out that I could use a metric ruler and just place it on top of here, slide it over till it hit that rod, and then take a measurement from the top of the cap. That seems to be the best way to determine if I've got this exactly parallel, is to just go to the half a millimeter, 0.4, 0.3. I can kind of tell that just by looking at this ruler. So if I think I just go back and forth, I can find that exact center. But then again, trying to get this clamped together so that this isn't just slipping all over the place has been really hard. So what I'm going to do is align this as close as I can. The spacing is correct. I'm going to go ahead and measure end to end, and I'm just going to see if I can feel where the edge of this fitting is with the cap here. And that'll tell me, where I need to clamp this down, and then I can check it down after I clamp it in the right spot. I'm going to try and clamp this in the middle, just hold these two together. But anyway, that's what I'm trying to do right now. As soon as I get the rest of these holes drilled on this fitting, that's going to be where it's going to stay. But I'm going to try and get the rest of these 8 holes drilled in these fittings, the 4 in the middle on each side and the 4 on the outside on each side. So after I get those in there, these rivets, by the way, I just stuck these in the hole just to hold it in place. Temporary sheet metal fasteners won't fit in here. There just isn't quite enough room. So, and they won't fit on the other side either because of the cap that's on the other side. All right, so I'm just going to keep playing with this until I get this perfectly aligned and get these holes drilled. And I'll show you what it looks like when I've got it finished. All right, so I was able to clamp this in the center and measure on both ends here to get them exactly the same distance from the top of that cap. So I'm pretty happy with this. The fitting here ended up exactly flush with the top, just like this one did. It's all square. So I'm gonna go ahead and drill the rest of these holes. All right, I've got the fittings all drilled, all 8 of the holes. They are in place, not riveted in yet, just stuck rivets in the holes, just hold it in there. I'm gonna check it with the rod one more time and just measure and see how close I ended up getting. In fact, let me just do that right now. And this rod, by the way, this is just a linear rail rod that I got off of Amazon. It wasn't very expensive. I think it's an H8 specification. So it's got fairly tight tolerances inside of this bearing. Well, can't do it one hand. There we go. Yeah, and there's a little bit of play because the rivets aren't screwed in yet. So it's not permanently fixed, but I'm basically taking the play out of it with this and measuring. We're about 56, almost 57. And we'll take it down here. 56 and a half. Yeah, 50. Yeah, it's exact. I mean, it's as close as we're going to get. I'm very happy with that. What we'll do is when we eventually connect the, the horizontal tail spar here and go to drill those parts, we'll make sure that this is perfectly 90 degrees to that assembly. So I'm not too worried about this. This is as perfect as I can get. Okay, so now I think I can take these apart, and then what I'm going to do is I'm going to clean this up and aladyne this, just finish polishing these fittings and cleaning those up and aladyne those fittings. Then we're going to have to spot stamp these bearings in place so they don't move. Then we should be able to go on to actually attaching the rear ribs to the spar here. So we'll keep working on this, and I'll get these all cleaned up and alidyned. All right, so I'm going to go ahead and try and install all of these rivets here on this elevator spar. These fittings here are not going to be riveted right now. In fact, I'm going to push the rivets back out. I was just using that to make sure I got them in the right position, that they were on the right side. But now after aladyning this, all the rivets that are not part of these 2 fittings here can be riveted all the way along where these caps were glued. So I'm going to see if I can get all those installed. I finished the riveting on the elevator spar. It came out pretty well. I did want to show you what I did to rivet this because there's not a lot of room on the back side here to pound these rivets in and put a bucking bar between this spar cap. It's really, really narrow. So what I ended up doing is I took my table and I actually just drilled a hole in it, and I stuck my rivet set in there for the round side of the head. And then what I did is I placed the rivet on top of, so the head that's sticking out here, I just placed that on top of there, and I had a block that was about exactly the same height just to keep this thing flat and from tilting. And then what I did with my rivet gun is I used a flat rivet set, and I actually pounded the back side of these rivets in with the flat rivet set. That was the only way that I could get these in there. I tried doing it the other way with the actual round head rivet set in the rivet gun and putting a bucking bar on the back, and I just couldn't get the bucking bar to stay on top of that head and to pound this in straight. But this actually worked really well, just using the flat rivet set. And that's what I did with all these rivets on the spar here. Now, I'm running into a bit of a dilemma here on this center section. So these fittings are supposed to be glued onto here and riveted in place. But you're not supposed to do that until after you glue all of the ribs onto the spar. you're supposed to come back and do that. The problem with doing this later is that it's going to be a little bit more difficult for me to get a rivet set and bucking bar in there to be able to set these solid rivets. But I also can't use this assembly until it's completely done to be able to square it up with the tail spar, which I'd really like to do. So what I'm thinking about doing is actually going ahead and installing these bearings in here and gluing and riveting these in place now. The drawback of doing that is you're supposed to take this and, you know, flip it upside down and glue all these ribs in place on the back side on a flat surface, and now these will be sticking out. One of the things I saw another builder on the internet do was actually create a jig that basically you could flip this over and these fittings would fit down into that jig to create a flat surface. And I think I'm going to try and do that same thing. I think it's better to install these now than try and install these later. And like I said, then I'll be able to square and, you know, everything up. Now, I did end up with a little ding I ended up putting in the spar web here. I was able to knock it back out and clean it up and fix it, but I had one rivet where the rivet set slipped and hit the spar cap. So I did have a spot I have to go back and repair. And I think what I'm going to do with some of these areas where I've had to go and fix and actually scuff up the allodyne is those are the areas where I think I'm going to get some primer. And after this assembly is assembled and glued and all the spars or all the wing ribs are on here, I'm going to go back and just hit those few areas with some primer just to make sure that they're coated with something, since I can't really go back and repair those areas with allodyne. It doesn't work very well, especially once rivets are installed. But you are going to make mistakes like this, you know, as long as you haven't structurally damaged this or weakened this area, as long as it can be fixed, and, you know, you're going to run into those kind of things. And that's what I ended up doing here. So anyway, just to let you know, that's what I'm thinking about doing right now, is go ahead and installing these fittings, which is not the proper order of assembling these parts. But like I said, I'll be able to take this then and lay it flat like this, line up the vertical spar on here, and, you know, with the pin in place here, and make sure that all of that is squared and drilled properly before there's any ribs installed on this. So the other thing I wanted to mention is I'm going to go ahead and install these bearings in here, and the plans recommend that you use a tool basically that you make that allows you to stake these bearings into place. And what that means is you're actually creating an edge on here, and you're going to actually go around the outside of the bearing and pound a little slot or a little indentation into the aluminum around it. And what it's going to do is, let me find these bearings here. What it's going to do here is these bearings on the edge have a little bevel on the outside of the ring here. And when these are installed into here, you actually are going to pound the aluminum. Let's see if I can get this in here. These are you know, precision reamed to the exact size of these bearings, so they're a little bit snug going in, as they should be. Okay, so I was able to fit this in here. But what we're actually going to do is we're going to try and move some of the aluminum that's around the outside of this bearing and just kind of push it so that it pinches this bearing in place. This bearing, I think, needs to be glued in place also. And then we stake around the outside of it about 6 to 8 times just to get the material to kind of push in there so that this bearing can't slide in and out each end. We're going to do that around each one, but the plans tell you to make a tool using, I think, 4 to 5 millimeter rod music wire, which is it's spring wire. It's basically specially heat treated so that it's very difficult to bend and it's very, very strong. So what I did is I picked up some 3/16 music wire off of the internet. This is from Precision Metals. And 3/16 is 4.76 millimeters. So this gives us a good 4 to 5 millimeter size to be used for creating this tool. And what we're going to do is just create a point on this edge with a couple different angles and make it so that we can go around this with a hammer and just pound these little slots that need to be put in there to try and move that material. But the other thing I'm using this 3/16 for is this is going to be used to create the tail skid on the rear fuselage that I was showing you earlier. You actually use this material and you bend it into the proper shape to make a tail skid on the back of the CriCri. So I'm using this for two different purposes because it seems to be the correct size for both, to create the tool for the installation of the bearings and then also use it to bend and create the tail skid. I'm going to start installing these bearings in these fittings now, since I'm at that point. I decided I am going to go ahead and glue these in and spot stamp them around the outside. I think that'll just ensure that it's in there as good as possible. I'm trying to protect the bearing here. I put some blue tape on the side that's going to be pushed in, which is going to cause the glue to want to come out of the bearing hole here. So I'm just trying to protect as much as I can from getting any glue on that ball. And then once I get it spot stamped, I'll take the tape off and I'll clean up around the outside with some acetone very carefully. I'm not looking forward to this spot stamping process. I really don't like just taking a chisel and pounding slots around the outside of this. I didn't figure out at this point a better way of doing it. This was a scrap piece here that I tested with, and it looks okay. I'm hoping I can do a little bit better job and take a little more time on the actual fitting here just to get it to look a little bit nicer. But that's the process, and unless I were to create a tool that I could use in a press or something to put those marks in there, there's not really a better way to do this. And in most cases, none of this stuff is going to show anyway. This is all be hidden in the tail. So as long as it's done well so that these bearings are nice and tight and don't spin, we'll be good. So I'm gonna go ahead and test this out, glue these in here and spot stamp these, and we'll see what it looks like. They look all right. The only thing I'm wondering about though is that, it says in the manual that these balls within this bearing should be stiff to turn, and of course mine's not stiff at all. Actually, I can turn it quite easily. It's not loose in the hole, but it's not tight at all either. Now I know we are using different bearings than what was originally specified in the plans, which was a bearing where you could actually take the ball out. It had horizontal releases, which we're not able to get those basically those type of bearings anymore, and these are the suggested replacements. This is an SKF bearing, so I'm using what's recommended of plans, but this isn't tight like the manual said that it should be. I'm not too concerned about it because I think the tolerances of these bearings are quite a bit different possibly, and with the not having the horizontal releases, I'm only going to get this as tight as the outer casing allows, because this is split. You can actually see a little seam right there on the bearing. It's split here so that this is, it's a one-piece thing that's been wrapped around. But if I look on the other side, I can't even tell where that split is. It's completely invisible, even though that split on this side goes all the way through. So it's not like this collar around this bearing is loose at all. It's not. So no matter how hard I pound on these spot stampings, it's not going to tighten up this bearing inside. So I'm going to go ahead now and glue these fittings onto the elevator spar, and then go ahead and get these rivets installed and try and finish up that elevator spar at this point. Once I'm done with that, I'm going to use that to align the horizontal tail spar and try and get those parts. Fittings riveted onto the horizontal spar. I use the same method that I did with all these rivets here, where I actually drilled a hole into my table and put my rivet set in there, and then drove these rivets backwards with a flat set on the back side. That seemed to work really well. I did finally have to take my 3/32 rivet set and actually put it in my lathe and grind it down a little bit, because it would not fit next to these fittings here like this. But once I did that, put some tape on it, it worked just fine. So.
I have just little tabs I need to just cut off with a razor knife. They actually come off very easy. So I'll just pop these out and cut them off, and I've got them all cut, this combined with the other panel that I cut. So they all came out perfect. I also have a set of rods here. These are actually the rods that I'm going to use to go through these holes that are put into these ribs. These are 3/16 inch rods, and what those are for is when we actually glue these ribs to the elevator spar, we're going to hold them in place by putting rods all the way through these ribs so that they're perfectly aligned when they get glued onto the spar. So these rods, I actually went to a metal supply shop nearby and was able to purchase 12-foot long stainless steel 3/16 rods and just have them cut them in half for me so they'd fit in my car. So these are about 6 foot long. The elevator itself is about 5 foot long, so they'll overhang on the outside a little bit, but that seems like it's going to work real well. What I'm going to do right now is I'm going to get a sheet of MDF and I'm going to cut out the forms that I need to use to support all of this in order to glue the ribs to the spar and actually get the skin then glued onto these foam ribs. I did want to comment, this stuff, at first glance, this stuff looks like it's flimsy and fragile. It's actually not. This stuff is super strong as far as twisting it. It doesn't crack, it doesn't bend. Now I can take two hands and rip this along these holes here and tear it if I want to, but this is not fragile stuff. So, stronger, much stronger than like balsa wood for sure, because it's a plastic material. So just want to let you know, this stuff is, there I go, I was able to break it. So if you do bend it enough, you can break it, but it's not on its own very fragile, especially when cutting it out. So you can be a lot more rough with it than it feels like you can be, because it's kind of gritty on the outside. It just feels like it would be really, really brittle, but it's not as brittle as it looks. So, all right, I'm going to get the MDF and go ahead and start cutting out the forms on the CNC, and then you'll see how all this is going to come together. I did not just break one of my ribs. I actually cut some out to test with before I cut the rest of these out, and this was actually a defect. I had some issues with the tabbing that I did on here with cutting it out on the CNC machine. I didn't tab it quite enough, so these moved around a little bit. And I was also doing 2 passes on the first set where I was cutting them out and then doing a finishing pass that was actually making them slightly smaller. The problem is once they were cut out, they were too flimsy, and so I wasn't able to take that second pass. When I cut all of these out, you'll notice I took 2 passes around it, but it was already at the final size. So in other words, it went halfway down this, about 1/4 inch material, and then did a final pass where it cut down through it and then did the tabs. So anyway, just want to let you know this was a scrap one anyway. So I've got several of them that ended up that way. Yesterday, before I left the shop, I finished cutting out the forms that we need to use to actually assemble the elevator. If you follow Shannon on homebuiltairplanes.com with his build, you'll recognize some of these forms. They're very, very similar to what he created for his elevator assembly. I basically just copied what he did, only because it's the easiest way to do this if you have a CNC machine. So one of the first things I did was I created this form here. I have it up on stands so that it doesn't hit the elevator fittings, but what this is designed to do is just hold the elevator spar in a completely flat configuration. Because what we're going to do is we're going to take these ribs and we have to sand and form these ribs around these spar caps so that these fit in to the spar at the correct locations. So what I'm going to do is, the next step I'm going to do is notch all of these ribs so that they fit in here. And this is going to keep that completely flat so that we can glue these onto the spar cap here, and these little nubs here allow us to just strap rubber bands around these spars and these rib assemblies as the glue is drying. And what we're going to do is those rods I showed the other day are going to actually fit through these 4 holes. These keep these ribs in complete alignment all the way down and allow us to strap the rods that are passing through here down to create pressure to hold these in place. So that's what this frame here is for, or this form is used for. And probably the only thing I did differently on mine is I actually did like a 20 thousandths recess here for the spar itself. That allows this to sit perfectly in place on here so that it didn't want to twist and slide sideways. So that was the only, I think, change that I made. Otherwise it's identical. So this over here. So this actually is intended to fit inside of this, and these blocks will go in here and keep it, perfectly at 90 degrees in here. So this actually will sit upright, similar to this. And what this is intended to do is support these ribs. I only got one hand to do this here. It's intended to support these ribs down in here like this. We're actually going to assemble this elevator slightly different from what the plans show. And by being able to cut this form out here and be able to use this form here upside down on top of here, we can actually use the form that we already have to create to support the ribs all the way across and evenly space them across there when we set them on top of here and glue them. The plans actually call out for you creating basically some strips of combing that have notches in them in exactly the same spots that these do, and you glue the ribs on top of here and you would just insert this combing on the outside. It was basically a board that was notched out, like a 1x2 or something is notched out to keep the ribs spaced properly as you glued them until they dried. But since we already have to create this form anyway, because once that dried, you were supposed to take this spar with the glued ribs on it and flip it upside down and set it on here and insert the ribs down into these slots in here so that you could glue the top ribs or the nose ribs on top, similar to this. So the spar would sit on top of here, the back ribs that we already glued would slide down in here, and then you glue these on top. What I'm going to actually do is, again, it's similar to what Shannon did, where I'm going to use this form to hold the spar. I'm going to notch and prepare these to fit in here in the right places. But then what I'm going to do is I'm basically going to insert these in here. We'll put the rods in here, and then I'll take this and flip this over upside down, or maybe lay it sideways, I'm not exactly sure, and actually use that form to keep the ribs spaced properly and glue the rear ribs with this. It makes it so I don't have to create those combing pieces, and it also makes it so that if I created those combing pieces slightly off and they didn't match this when it was cut, then the ribs wouldn't fit in here after they were glued. So again, by using the same form for spacing, both for installing the rear ribs and then to assemble the front ribs, we're going to make sure that everything's aligned the whole time to the exact same spacing. So that's what I'm doing with this. And like I said, the first thing I'm going to do is notch out all these ribs to fit in these spots. And I just ran tape down the slots, and I left a little gap underneath here so I could get tape underneath and actually mark each one of the rib locations with tape. I'll take the comb off here, and then I'll go ahead and take the spar out of there. I'll secure the tape a little bit better, and then I can start fitting the ribs to each one of these locations in between the tape. So these were cut out pretty much the right size. I did have to notch this out a little bit more in the middle, but what we're trying to do is get this rib to fit between these two spar caps perfectly, right inside of there. Now, believe it or not, this rib on either end is supposed to stick out from the edge of the cap, and it's supposed to be actually wider than the cap by about a half a millimeter, maybe a millimeter, right around there. And when we get done with gluing all of these ribs onto this spar and we get to the point of gluing the skin on, the skin does not get glued to the cap. In fact, there's actually supposed to be a tiny little piece that is glued in between the back rib and the front rib on top of this cap. That 1 millimeter piece, you're actually supposed to fill that with a tiny little piece of this foam material. In order to make it so that when you glue the skins, it's not supposed to be glued to the spar cap. It's literally the skins are glued to the ribs are glued to the spar, and that's how the force is transferred. So I'm going to go down this spar here and basically fit each one of these. And the reason I have to fit each one is that as you go down, the spar cap itself starts to get taller because we made a taper in that spar cap. So as I go down, I'll be notching up the sides to get these to fit all the way down, and they need to fit right in between here. And the reason I'm starting at the end here is not just because it's the end, but if I, let's say overcut this or over notch this, I can use it as the next rib down. So because as they go down to the center, they get taller and taller and taller. So I'm just trying to make sure I start on the ends. If I start overcutting them or something, I can then just move that one down and use it in the next spot. So that's what I'm doing. All right, I was able to notch all of the ribs. And you probably see here, this is one of the inside ones where I had to notch a little bit more. They taper down to the end ones where there's just the notch to get past the inside of the cap. So this is one side. There's ones in the middle here. I actually had to notch out for the rivets because there's two that get doubled up back to back here, and they just have to get glued in around the rivets. So you just got to kind of maneuver them into place and just kind of clear the ends of the foam where they're going to hit the rivets just so they fit down there flat. So what I'm going to do now is go through, and every place where I've got tape on either side of where the rivet's going to go, I'm just going to take a little bit of sandpaper, some Scotch-Brite, and just take the allodyne off in between. It's easy enough to do. And then once I've done that, I'll take the tape off, and then I'll start preparing the ribs to actually glue them in place. I had to modify this frame a little bit. Hopefully you can see here. What I did is I took my Dremel tool and just rounded off the corners here, because as I pushed these down and put the spar cap on here, I didn't want this frame to end up getting glued to the ribs with the sharp corner there, because the glue is going to squeeze out a little bit on either side. So I just gave myself a little space because I don't want to glue this to the spar cap or to the spar web. And these center ribs, these actually have to be glued together because this is two 6 millimeter ribs. I got to glue those together first, and then these rods end up going through these holes here, and here, and actually grip on either side of this frame that we have here. So there'll be 4 rods, 2 on each side. It'll hold them in here, and then we'll be able to just set the spar web on here basically upside down. I'll set it down on here, and then I'll strap it to it, and I think that'll work quite well. This wasn't designed to be used like this. This was designed to be glued on a separate step and then put into this frame to glue the top ribs, but I think this frame's going to work even better to just use it for both. So I did glue these 2 center ones together. These were 2 6 millimeter pieces. I glued them together, let them sit overnight, and then I went ahead and installed all the ribs back into this spacing board here. And then I stuck these rods through all the holes that were pre-drilled into those ribs. So you can see I was able to slide those all the way down, and it keeps these ribs perfectly centered on this board. And if you look, I think, let's see if I can take a shot down the end here, you can see they're perfectly flat. There's variations on the edge because of the notches that were created for the spar as it tapers down, but pretty much perfectly flat on top. So the goal then is to just apply glue to each one of these ribs, and then we'll set the spar on top of here. We'll put the other board that I had created and cut out that fit that spar, and then we'll just go ahead and put rubber bands around the little notches I have in that board around here, and we'll rubber band it down to just put some pressure on it to hold it down. By the way, putting these rods in, I got some blisters on my fingers already from doing this. I was able to slide 2 on one side by hand, just pushing it in and turning it at the same time as I pushed it all the way through. But of course it got tighter and tighter and tighter as you went down to the end. What I did on the other side then is I made sure that I pushed these ribs all the way up against, so these metal rods were flat against here. They were all perfectly level. And on the other side here, I was able to just insert one into the first few ribs, and then I used my electric drill on the end and just spun it and pushed it, and it went all the way through and popped out the other side, because of course those holes are completely aligned all the way across. Plus I tapered the ends of these into somewhat of a point, so they'd find the hole. So that's how I got all 4 of these in here. I'm gonna have to use the drill to get them out too, because I'll just turn the drill on and just slowly pull them out. Yeah, we'll start gluing this. I just set this spar on top of here just to see what it would look like, and it snaps right into place here with where I cut out those ribs. And you can actually see on the end here how the rib sticks out slightly farther than the spar. It's about 1 millimeter on the top and the bottom, and it's like that all the way down. What I like about doing this way is it's very easy for me to see when I put glue on this and set the spar on top of here. If I've got everything lined properly, like I said, it literally snapped into place, locking itself between those cutouts and those ribs. So looking at this right now, I could literally just glue this on here and just set a few weights on top of here, and I'd be confident that this was going to stay perfectly flat and straight. But what I am going to do is use this board that is cut out on the other side to fit the spar. I will set this on top once I get the glue on there, just to keep a little bit of weight on it. I'll put a couple rubber bands across the holes just to hold this board down. Really, it's not pulling the ribs up or anything like that, but this will be plenty of weight to just get some tension on top of that spar for the glue to dry. So I'm plenty happy that that's going to work out just fine. Epoxy on top of there, not too much, just enough to hopefully glue it down, and it'll squeeze out the side a little bit, which is what we want. So I'm going to go ahead and set that spar on top of here, and we'll get this board on top, strap it down. The only thing I did is I went back around, and any place where I had a bead that was sticking out here, I just cleaned that off, because we have to fill in on top of this cap here between this rib and the rib that goes in front of it for the nose rib, and I just didn't want to have to work around a big, a round ball or a blob of epoxy sticking up in there. The other thing I did is I just cleaned off the end pieces there so there wasn't anything sticking off. Just trying to limit how much I have to clean up afterwards. You do want to get a nice, let me see if I can find one here. See if you can see that up in there. You do want to get a nice bead kind of a glue coming out the edges of the ribs. That's actually good. Adds to the strength a little bit. Yeah, you can see I got a nice little ball of glue coming out the side there, which is good. Don't want to put too much on so it runs, but you want to put enough on there that it creates a good glue joint. Okay, so I'm just going to leave this sit overnight. We'll come back tomorrow. I'll take the top off here, and I'm pretty much ready after that to just do some cleanup and do the nose ribs next. So we should have this the rib work here done pretty quick, and then I can finish the center ribs, which are metal that have to be formed for the elevator control fitting, and then we'll be working on the skin. The glue is all dried. It looks perfect, and what you really want to check is as you go down each one of the ribs, you should see the ribs sticking out equally on each side. It's literally 1 millimeter on each side, and what we're going to try and do now is first, after I took this top piece off here, I went ahead and drilled a hole in each end where the metal rod needs to go through. I just put this up here and just marked a hole and drilled it through. And that's where another metal support rod's going to go through to hold these nose ribs on top, like so. So what we're going to do is prep for gluing down the nose ribs, and I'm going to kind of use the same procedure. I'll just tape on either side of where these ribs go across. I'll remove the allodyne from those areas. I will glue, or then prepare to glue these nose ribs down, and once we get to that point, we'll be able to put some epoxy on those and strap those and rubber band those down in place, and we'll let those sit overnight tonight also. And one of the nice things about gluing the spar while it's in this comb assembly here is that I didn't have to remove it and install it in here or try and fit it down in here. It was already in here when I glued this, so now I'm already at a point now where I just need to prep and glue these down next. So again, I like this method of gluing this spar web inside of this comb assembly with the rear ribs already in place. I think that's the most efficient way to do this, and also the best way to keep all of these ribs completely square and straight and get them positioned properly. So I think Shannon had the best idea of how to do this, and that's exactly what I did here. So I'm gonna go ahead and prep all this, and I'll show you what it looks like when I'm ready to glue. All right, it only took me a few minutes to, tape off and remove the allodyne from the locations where the ribs are. I just lined up the tape on either side here and just ran some Scotch-Brite down it and took the allodyne off. So I set this rod in here, and I just temporarily placed all the ribs at the right location, because what I want to do is space these out exactly where they need to be on the metal rod, because they don't slide on the metal rod. They're kind of, pressed into there somewhat. And then I'll just slide the end rib down a little bit. I can push the whole rod this way and pop the whole rod out. So at least then I have proper alignment here. And then I think what I'm going to do is, instead of applying the epoxy to the ends of the ribs, I think what I'm going to end up doing is actually just applying a bead of epoxy across the shiny spots that I created here, because that's exactly where the center of the rib needs to go. And then I'll be able to maneuver this entire thing on this rod in here, and what I'll do is I'll prop it up in the middle when I install it, so that all these ribs, except possibly the end ones, will actually sit up in the air, and then I can get them placed exactly where they need to go before I lower it and put rubber bands on it. So the other thing I'm going to do is, I picked up some balsa wood. I was going to use toothpicks, but I decided to use some very thin strips of balsa wood to put between this rib and the one below it, so that I can strap a rubber band in front of it and below it, and actually make sure that this rib is not, sliding off center from the other rib, because this needs to transition from the back rib to the front rib. Has to be perfectly flush on both sides. So I'm just going to cut some like 2-inch strips or maybe 3-inch strips of this thin balsa wood material that I'll just put across here, strap some rubber bands on it, and it'll make sure that these edges stay perfectly aligned, not only this way, but they stay flush top to bottom with the ribs that have already been installed and glued on the bottom. So that's what I'm going to work on next. So here's the balsa wood I was talking about. I just picked up 36-inch long, I think it's 16th inch by 1/4 inch strips of balsa wood. And the reason I picked balsa wood is I didn't really find anything else at the craft store. I was originally going to use popsicle sticks, but popsicle sticks are actually quite a bit wider, and they're really, really stiff in comparison to this. This is actually fairly flexible, and I think with some rubber bands it'll just conform to the shape of the rib, which is all I wanted to do. I just wanted to keep the shape and be able to at least pull it tight so it keeps those two front and back ribs completely flush. So I picked up 3 of these 36-inch long ones. Just worked out. I'm just cutting them into 2.5-inch strips, and then, like I said before, what I'll end up doing is, I'll end up just strapping that with a rubber band on the top and the bottom between the 2 ribs, just to try and keep these perfectly flush. And I'm going to see if I can strap the bottom one here before I put the top ribs in place, because it'll help guide it right down the center when I place them in there. So I'm going to go keep working on this. I'm going to cut the rest of these up, and then I'll start preparing this for glue. I'm ready to actually glue this now. I just kind of did a test run. I put these little strips of balsa wood here, like I said before. I just strapped a rubber band around the bottom of it, and then I wrapped a rubber band with a little piece of dowel just to hold it around there, so that I can take this and just slip it over the top of these balsa pieces, and I'll just put the rubber band around there. I'll get it really good and centered then, and just move my way down after I've got the glue applied, and we'll get these all glued in place. And then what I'm also doing is I just took a piece of dowel and just stuck it around the top here and just wrapping a rubber band around the the lower rods here, just to pull this rod on top down, just to put some little bit of pressure on these ribs while the glue is drying. But I think this will work pretty well. Luckily, I've got a lot of working time on this epoxy. I think it's 50 minutes or close to an hour before it actually starts to set up. So I've got a lot of time to at least maneuver these into place, make sure they're perfectly straight and aligned properly. So I'm going to start gluing. All right, I've got the glue all on here. These all seem to be aligned pretty decent here. You do want to have a nice bead coming out the side of these ribs. It adds a little bit of strength if you can just kind of let a nice fillet kind of form around the outside. So anyway, this looks really good. I'm just going to let this now dry overnight. We'll come back tomorrow and we should be able to take it apart. Now, I could end up here with some glue that ended up getting on these balsa sticks. I'm not really too concerned about that because the balsa is very soft. It should just pop right off. And if I need to sand a little bit right there, I can just to clean it up. And then we actually have to go back and fill in between these two ribs on top of the spar with a little 1mm cap that we're going to glue on top of there. So we might have to do a little bit of cleanup in between the ribs, I think, in order to even get those pieces in and get them glued and smoothed out nicely. But as you get down here, you can see there's a lot wider gap here at the spar that we got to fill in. And I tried to avoid getting too much glue that would have squeezed out on the end here. Since I have to go back and fill that anyway with glue, I wasn't too concerned about getting it too close to the edge. But this strapping method worked really well. I think we've got a nice little gap, which I can see in between there on each one of these, which really tells me that they're in the right spot as we go down the line here. Yeah, you can see that little gap there. That's what we want, because that's what we're going to fill in with a little bit of additional foam material. Okay. All right, this looks great. I only had an issue with one of these balsa sticks that stuck. It ended up sticking right here. I'll just have to sand off or grind off that little piece. Otherwise, the rest of them all just popped right off. Now, I did find out last night after I went home and read the manual that I actually made a mistake. Apparently, I was not supposed to glue these two ribs in yet. And the obvious reason is we have to put pop rivets into the sides of these brackets here where there's some aluminum ribs that we have to make that get installed here. And if you've got a pop rivet gun similar to mine, it does not fit in here. So I haven't decided exactly what I'm going to do, although I know the head on this pop rivet gun is fairly big. I think I can find a smaller pop rivet gun at Harbor Freight or something like that. The distance is the head has to be 2.5 inches or less in order to fit in here and be able to pop these rivets. So I'm going to have to search and see if I can find a replacement pop rivet gun. I honestly have not been happy at all with this Arrow pop rivet gun. And this is just a home store pop rivet gun that you can get at Lowe's, Home Depot, that type of thing. The rivets keep getting stuck in this pop rivet gun. I used this extensively when I built that frame to heat the foam for the ribs. And of course, every time I tried to pull a rivet, it would get stuck where it wouldn't allow the rivet gun to go back in to re-grip the rivet again, to pull it again. It constantly got stuck. Creating the metal ribs that go in the center of the elevator. So what I've done is I've just cut out some forms here, and the reason I have the up arrow on mine is that mine are not cut symmetrical. I decided to do the rivet eliminator option for the upper skin on the elevator So the top side of these is actually 20 thousandths of an inch closer to the middle of the rib than the other side is. Because we're actually going to, with the rivet eliminators, when we create these ribs, we're going to actually attach a piece of 20 thousandths material, similar to this. I believe it's 20 thousandths, that gets glued to the top side of these rivets or these ribs that we create. And what it allows us to do is we're going to rivet that plate to the top of this, and then after we install these ribs, we're going to glue the skin onto the top of that aluminum plate that we rivet internally to the top of these ribs. So I'm going to attempt to do that. That's the only reason why I created the up and down, because these need to be matched this way. When the rib is formed inside of here, I need to keep track of what's the top versus what's the bottom, so that I don't get it upside down when I install it. So what we're going to do is these forms, what we do is we basically take this piece of aluminum. It's got the holes marked for the same, to line up with the holes in this form that we have. And what we're just going to do is sandwich that between these wooden forms, and we're just going to shape and bend these pieces around into the shape of this MDF form that we created. Now, I've got to do some work on these before we actually start bending. I've got to round the edge so that when we bend the aluminum around it, that we are radiusing the inside corner properly. The other thing that I probably am going to do is put some relief notches into the sides of this form, because once we bend this over, it's not going to want to lay flat along here because of the curve that's created, this kind of compound curve that's going in here. So we're probably going to have to pound down some relief edges on each side just to get these to flatten out and get straight. Now, this might take a few different tries, I think, probably to get this to work right, but I'm going to attempt to do it here. So I'm just going to start out by clamping, or by modifying these forms a little bit, cleaning them up a little bit, get these two pieces bolted on either side of a piece of aluminum, and I'll pound it into shape and we'll see what it looks like. Shape my first rib. It actually came out pretty well. It'll be interesting to see how well it fits, but what I ended up doing with the form is, of course, I rounded the edges here where the metal was going to fold over, but then I just took like a 1/4 inch rasp file and just started filing these slots in there after I bent it. The rivets should be located in between here, so I tried to space these evenly across here where they were meant to go. But what you want to do is taper the file so that it doesn't dig into the edge here that's being bent over. You want to go right up to the edge and then kind of file down at an angle just to create a little pocket. And then what I ended up doing is, once I had that pocket formed, slide this in here. With it clamped together, I just went around the edge here with a side of a punch and just hit it with a hammer to pound it down into the little recesses there, as you can see. And of course, what you're looking for is a perfect flat between each one of these that creates the shape. So you want to be able to take a piece of metal or a ruler or something and lay it across the top here and make sure that where your rivets are going to go, that you end up with a perfect profile of the rib. So anyway, that one worked pretty good. I'm going to try the next one, and we'll see what happens, see how they actually fit once I line them up with the center of the elevator where they're supposed to be positioned. So I thought I'd show you what I'm doing here with these forms that I'm using to make the metal ribs for the horizontal tail. So all I'm doing is the side that I'm going to attach the aluminum to, that's going to be bent over. What we want to do is we want to round this edge here just with some sandpaper, just enough to make a radius for the material to go around. And then once we bend it flat, because we're taking a piece that's vertical and making it horizontal, it's going to want to stretch. And so we have to take up the extra aluminum that was vertical and is now trying to lay flat by basically pounding in some some relief spots within the metal to stretch it, or not to stretch it, but to actually shrink it along this side by knocking it into the by knocking the extra material into these flutes that we're creating. So all I'm doing is I'm just taking a 1/4 inch rasp file and just rasping in a groove inside of here. And what you want to do is make it fairly deep, maybe half the rasp deep on the outside edge of this 3/4 inch piece of MDF, and we want to go right up almost to the edge, but we don't want to cut into the edge because we don't want to knock a dent into the corner. So just before the corner, you want to stop and make these all the way along here on both sides. And then, so that ends up looking like, similar to this one, this is the one I already used to knock out the first piece that I did. And it seemed to work pretty well. So after you get done creating these recesses for these flutes to be pounded into, and you've rounded the outside edge, you're going to want to take the edge off of the outside of each one of these recesses. If you created, you want to round those pretty well. This is the first one that I did, and you can see I rounded a lot more down at the bottom just because you need more bending ability to shrink the side to straighten the part out on the bottom than you do here at the top, because the curve gets a little bit more down here at the bottom. So just with some sandpaper or a file or something, just knock the edges off of those and round them a little bit. That's what it should look like when you're ready to form it. I just put 2 1/4 inch bolts that were long enough to fit through. You can use nuts, whatever you want on the back. I just had these laying around from my CNC machine from bolting things down. So you can see what we're going to do is we're just going to take our hammer and we're just going to start knocking this lip down and bending it flat. But you'll notice as you start doing it, it'll just start to ripple because it won't flatten. It's taking something that's longer and trying to make it shorter by bending it flat across here. So you just try and get as close as you can. Then you start, I start at the top here, and I'll go along here and just use my punch on its side, and I'll just hit it with the hammer just to get that material to go down in the recess. Like when it's basically pounded into shape. And the only other thing I could do with this form, and it would actually be recommended, is you can see there's spring back. So I can't knock this all the way 90 degrees. So one of the things you can actually do is sand an angled edge on the outside edge of these the form you're doing. And what that'll allow you to do is kind of push this metal past 90 degrees so that it'll spring back. I didn't do that, and part of the reason I didn't do that is this is only 20 thousandths material. It's actually easy enough almost to bend by hand. So my plan is to just pull this out of this form, and I can just reshape it, bend it by hand just to push it back to 90 degrees and fix any of the minor imperfections that are in there, and then Scotch-Brite it, clean it up just to get some of the minor tool marks out of there. I bent the edges all the way around basically into about 90 degrees, maybe even over just slightly. But then you'll probably notice when you get done to that point, it's got a little bit of a curve to it. In other words, it's kind of dished out a little bit like this. If you lay it flat, it can feel a little bit springy in the middle. So what I do is after I've straightened out everything so it's perfectly 90 degrees, I actually will put it back in this form, and then I'll just hit the fluted areas one more time just to try and shrink the sides a little bit to just pull this straight. That seemed to work good on the first one. I'm just going to try that again on this one, and I think I'll have it done. It is nice and flat now, which is good. Yeah, this looks pretty decent. So the only thing I would caution you on is when you first put this in the frame and you start bending this lip over, don't keep pounding on that lip all the way up and down, because what will happen is you're just going to keep moving the stretched part all along there back and forth. You'll notice there'll be a little bump in it because you folded it over and it won't lay flat, and then you'll pound down here, and that bump will come up here, and you'll pound up here and the bump will come up down here. So what you're going to do is end up work hardening it and cracking it if you keep just pounding on it. So what you really want to do is just bend that flange over, just start to get it bent over, and then start at the top here and flatten one section as much as you can by just pounding it down flat, then hit this flute in here. Then go to the next part, pound it down flat, and hit this flute here. And then keep working your way down the rib and you'll find out that you'll be able to shape it fairly quickly. But like I said, just minimize the amount of initial bend over that you're doing before you get a part at least flat enough to put a flute in it, because you'll just keep moving it around, like I said. So yeah, this looks pretty good. Fit these nose ribs in here. I was only able to clamp one in place right now because I don't have room enough to get 2 clamps in here, but these are actually fitting absolutely perfect. So what we want here is, first of all, I attached 4 pieces of angle across here, and what I'm trying to do is get a reference point of being flush with these ribs with these metal ones here. So if we look, what I've done is this rib is resting on this angle, both sides of this angle and both sides of this angle. And I think you can see, if I go down the middle here, you'll see that it's touching, both these and both of these. Now, because I'm doing the rivet eliminator on the surface of, or the top of the horizontal stabilizer, I've actually should have about a 20 thousandths gap between the rib and this angle, which I don't know if you can see down in there, but I actually have a gap of almost exactly 20 thousandths here, here, and down here between these two also. So this couldn't be any more perfect than that. And I did fit the other one in here roughly. Oops. And I ended up with the exact same fit. What I'm going to do is check out here to the nose, because that's where a little bit I'm concerned that might be a little bit too tall, but we'll have to see, because it's the only place where there could potentially be some problem. But otherwise these look like they're going to work absolutely perfect. All right, so what I'm going to do next is I'm going to work on the bracket that needs to be installed in here that's going to hold the horizontal control fitting, which actually gets mounted down here, because that'll help me get these 2 pieces connected together in a little bit more rigid form, so that when I go in here to actually mark and drill these holes in here, I'll be able to do that. Now I'm going to have to get an angle drill to come in from this side to be able to drill these holes through here. So I'm working on the plate that needs to get installed that is designed to attach this fitting to, and this gets bent at these different 4 spots, 4 corners here, and ends up getting installed between these ribs here. Once I shape it, you'll see what it's going to look like. But what I did is I made this block, and this block is exactly the internal dimensions of this folded piece. And so what I'm going to do is I'm actually going to attach this to this plate, similar to how we formed the ribs, and I'm going to bend this around this inside form. I do have to round radius the corners on all 4 sides so that I create the radius when this gets bent around here. But I'm going to use this to form and shape this piece, because this is a fairly thick piece. This is 63 thousandths. This would actually be pretty difficult to bend, or impossible to bend on my bender. It's kind of like the tail pieces that I had to build for the aft fuselage, where this kind of just needs to be bent by hand. But I think I can do it if I've created this form to basically form it around, and I've radiused the corner. So that's what I'm going to do, is attempt to bend that right now, and we'll see if that can fit in between these ribs here. I tried to form this part around this piece that I made. I didn't make the radius big enough, and I don't know if you can see there's a hairline crack all the way along that bend there. So and just so you know, this fitting that I stuck on here, I just used this to hold the bolts and to bolt this together. This fitting was one that crashed in my mill, so it was a junk piece. But what I'm going to have to do is take this apart, and I'm going to have to take this form that I made and radius the corners quite a bit more to make sure that when I bend this, it doesn't crack. All right, so after I rounded the sides of this piece a little bit more, radius a little bit more, I stuck the broken piece in here and just bent the other side just to see if I could bend it without it breaking, and it bent fine. So I'm going to go ahead and cut a new piece and stick it in here and see if I can bend all 4 sides. All right, what do they say? The 3rd time's a charm. So I broke the other one I did, so I had to actually radius this even more, but I was able to successfully get the 3rd one to work. It does have big radiuses on it, but it's not going to be a problem. I can still get the nut plates in there. So, and I measured it. It's actually the perfect width across there between the ribs. So this will work just fine. I'm going to clean it up and see if I can get this fit into the front ribs. The wonderful thing about working on a CriCri is you get to make things over and over and over again. You get to do things several times. So, okay, I screwed up on these ribs. I have to make new ones. And here's the reason why. The holes that I put in to bolt this between these forms, this hole's too far forward because this actually has to fit inside of here like this in the front. And there's got to be 3 rivets that go through the side of it, 3 rivets that go through the side of this that go into here. And this is overlapping my front hole here. So that's not giving me a very good space to put 3 rivets in there. So I got to make these over and move this hole back. The other thing I found out is that because this has to be fit up in here, we have to make sure on the bottom here that the flute that I put in here has got to be moved back. I have to leave enough space to clear that bracket with that first flute and then do 4 flutes right on the edge of that. So I'm going to create some new forms here. It's not that big a deal. I can just cut those out real quick. I'll just have, I spent more time creating these little flutes in those spots. Yeah, I'm going to go ahead and cut out some new parts. We'll just rebend these, not a big deal. At least I have this bracket done. This actually looks like it's going to fit well, so once I get these set up, we'll be able to go ahead and drill the holes in and connect this together. Yeah. So I made another set of rib forms here. What I ended up doing is locating this first flute here about 28 millimeters from the end, and then the rest of these are about 18 millimeters apart. That seems to be able to clear the bracket here. Obviously I moved my screw hole over a little bit, so that's not in the way of that bracket either. And I'm going to go ahead and bend these too, and hopefully we'll have some final ones that we can use. These actually came out better than the other ones. It's one of those things where, practice helps. So I was able to get these formed them nicely, and they're perfectly square. So these should fit in there. I'm going to start working on fitting that front fitting in there. Okay, so I fit this fitting in here and ground down the edges like we're supposed to. And what I did is I put this fitting in here and just marked with a pen on a piece of paper around the outside of it so that I could try and mark the holes. They're supposed to be on the bottom 12 millimeters apart and 5 millimeters from the edge, and then the top one's supposed to be 5 millimeters from that peak. So I think I got that pretty close. What I'm going to do is just drill these out with some 16th inch holes, and then I'll place this in here and I'll mark where those holes are in the bracket just to make sure that I'm on track with them lining up with the sides of this. If they line up, I'll just butt these 2 ribs side to side and drill all the way through, so I mark all of the holes on both ribs at the same time, and then I'll go ahead and mark them on the bracket, and we'll get those drilled in place. This is kind of a weird setup here, how this is supposed to work. This is supposed to be basically flush with the bottom, similar to that, flush with the bottom of the rib. But then what we're going to do is actually make a plate that goes over the top of these holes here, and we're going to taper that plate so that it matches the curvature of the skin and the outside edge of the rib. Apparently they want that being perfectly flush all the way with the skin, so that when we bolt this, the flight control fitting on here, that it doesn't compress the skin and that it's conforming to it. So I'm going to finish aligning all this stuff and get these holes drilled. So I was able to get the holes drilled out for this bracket that we're installing between these 2 ribs. And I now have these ribs fit in this center section here. I I think what I'm going to do at this point is actually separate the fitting out of here, because what I'm running into a little bit of problem with trying to adjust these ribs is that any misalignment with this fitting at all, these angles being a little bit off, just these two ribs are actually fighting each other just a tiny bit. So when I move one so that it's completely flush with the other ribs across the front here, the other one's off just a tiny bit, and then I'll move that one to get that one aligned. It'll push the other one off. And I think what I'm going to do is remove this and actually align these ribs perfectly where they need to go individually, and then get the the holes drilled here through the bracket and get these held in place, and then come back and put this fitting back in and just double check and make sure that it's bent perfectly straight and that the angles are perfectly right, so that when I put this in there, it doesn't misalign these ribs while it's being inserted. So I think that's what I'm work on next. So I got the two ribs installed here with temporary fasteners, got all the hole drilled. I got a nice flush finish on the edge here between the ribs, so pretty happy with that. I'm now going to work on this little piece that has to go in here, that has to be kind of just shaped and fill in this little gap between the rib here, and taper it so that the fitting will attach there and be flush with the skin. The fitting itself on the base has to actually be curved out on the bottom to fit with the skin also, so I'm going to work on that next. This is basically cut out of 40 thousandths aluminum, and it fits basically right down in here. And what we have to do to this is we actually have to sand it down into a slight curve on the surface so it follows the same profile as the exterior of the rib. And I think what I'm going to do with this is I'm going to use the same technique I did with those plates that we had to curve on the wing panels, where I'm just going, or taper. What I'm going to do is I've got double back tape on the back of this. I'm going to stick it to the back of this, and then I'll be able to go over to my disc sander and just kind of curve this edge gently and sand it down a little bit. I think I should be able to get that ready pretty quick. So I'm going to go do that now and see if we can round that off. Okay, I spent some time on the sander sanding this down, and hopefully you can see there's a slight curve to that. That's basically what you want. It's just supposed to follow the profile of the rib. I might have to sand it down a little bit more, but that's basically supposed to fit down in there and conform to the ribs. So I'm going to sand this down a little bit more. I'm going to take this off and stick it in here and just see how close I am with a straight edge across the ribs, but I think it's pretty close. I've been working on checking the fit of these two ribs in here with the skin and the other ribs by using just a straight edge and just kind of rolling it up and down, checking for high spots on both sides. I don't like the way these fit. I wish these fit a little bit better, but we're taking a piece of sheet metal and we're bending it on a wooden form with a hammer and then expecting perfection. It doesn't turn out perfect. So I've tried to make sure that I don't have any high spots along any of these. When we glue the skin on, we're putting glue on the ribs, and we're putting glue on these ribs too. We're not going to drill the holes and put the pop rivets in until the glue is dried. So any low spots will likely be filled a little bit with glue, and I'm not talking about big low spots. I'm talking about a hundredth of a millimeter. I mean, we're talking really, really small differences. But what I did find out is that once I got these ribs in place, there is no way that I have enough room to put another 20 thousandths piece on top of here to do the rivet eliminator on the top of the skin, and I've just decided it's not worth the effort of trying to do that. If I come around to the other side here, so when I run my straight edge across here, across the ribs, the only place I have enough room that I could put 20 thousandths is right down here in the end. It's the only low spot that I have all the way along here, and had I done this again, what I would have probably done is pop riveted this or riveted and glued the doubler that was going to go across here to do the rivet eliminator on the ribs before I drilled the holes and installed them, because getting these ribs in place and getting them positioned right up and down, back and forth, this way, and having everything line up all the way across the ribs is really, really difficult to do. So I thought about remaking these ribs. I just think that if I remake these ribs, I'm going to create another problem for myself that I didn't already have. Now, the only issue I have, I've got perfect alignment across the back. I've got perfect alignment across the front. The only low spot I have is here and here. And I think what I'm going to do is when I fill across the top of the spar here with the little filler piece that's supposed to go on top of the ribs, because if you see these stick out just a tiny bit, and we're supposed to glue the skin to the ribs, that has to transition from here over to this rib here. And so what I'm going to do is maybe put a small piece of filler on top of the ends of these ribs of the foam that I can shape, sand, and get the transition really smooth from here to here by just putting a little pad basically on the end of this that'll be tapered, almost completely gone by the time it gets to the end of this one, because when I get to the end of this here, it is level across. And I think that's going to be the best way to make this all look good in the end. Like I said, if I try to remake these, I think I'm just going to create more problems for myself, and I might as well just say that's close enough. And when I'm saying it's off, we're talking about, you know, half the thickness of this is what I'm off anywhere. So, you know, 10 thousandths of an inch.